name's Blaine Carter. I'm Oracle's developer advocate for open source. So what that means is I kind of work at the intersection between open source and the Oracle database. So on the one hand, I try and find projects that are, open source projects that are useful for database developers. And then on the other hand, I can help, if there's an open source project that might need a little bit of help with database development, I can help with whatever they need there. Today I'm here to talk about Bluetooth beacon tracking on a budget. Bluetooth beacons are pretty much any little device that sends out a Bluetooth pulse every once in a while. So if you think about when you put your Bluetooth headset into pairing mode and it's sending out here I am, your phone finds it and connects, technically that's a Bluetooth beacon. There's a whole bunch of different form factors you can get. This one, the beacon part, is just that little tiny circuit board. I don't know if you can see that there from the part that I'm not covering up. There's some other ones there. Basically, this presentation came about from a contest I entered. It was just wrong thing. It was a geekathon I entered after a conference where I went to a conference and they had these beacons on the back of our badges. And then they had sensors everywhere throughout the conference. And as you would, so like come in the room here, they know exactly how many people are in, people left early, came in late, that type of a thing. And after the conference was over, they had just a geekathon come up with a need for to use the beacon and solve the problem with the beacon. And so I'm going to show you just a little piece of the video here. Let me start probably right about. This was my entry for the...
Howdy, I'm Blaine. My son Alex has a few bonus features, and he attends a school with other exceptional students. Every once in a while, some of those students try to wander away, and that's not good. Now, there are some commercial automated systems out there that could help, but they tend to be real expensive. So when ODTUG started another Geekathon this year, looking for interesting projects involving the badge beacons, I thought, hey, I'd try my DIY skills out on building a more affordable option. What happened is first phone, and we get another notification, and the front door, the deadbolt will lock. As he approaches the Raspberry Pi in the hall, we're going to get a notification on our phone. Next, when he gets near the Pi by the front door, the deadbolt will lock and we get another notification. And finally, once he goes outside near the last Raspberry Pi, the deadbolt will unlock and we get a final notification.
I don't want to lock him
Then
out of the house.
after that, I'll show the deadbolt actually turning, and we'll get to hear the text-to-speech notification in the background from the Sonos. So, all right, here we go.
Howdy everybody, this is my boy Alex. Say hi Alex. That's the whole reason I showed the video. I like to show my boy. He's wearing the happy birthday badge from last year's K-Scope with the beacon hooked onto it. And so now we're going to test one of these this system out. Okay, come this way Alex. Okay, first we're going to go over this way and we're going to open the door. And you'll see out here in the hall we have a Raspberry Pi that is detecting the beacon. Okay, so come over this way. This Pi right when here. He gets close enough, he's coming. Okay, stop right there. Alright, then we should get a notification, there it is, from there saying he's left the room. Alright, so let's go this way, Alex. So come over here and stop. No, leave it. Okay, he's fixing it. Alright. He's kind of like
so stop
me.
right here,
not just
and
right,
you'll see the front door is unlocked. Okay, stop right there. Stop right there. I have another Raspberry Pi hooked up right there. And you should see, oh, there it went right there. The door locked, and we got a thing saying he was by the front door. Alright, so now go outside. So now if he were to make it outside, then I have another one out here on the chair that when he gets close to that, you'll see, oh, I missed it, the door unlocked, and we should now get a third one saying he made it outside. So, system is working. I noticed on the previous video that I never actually showed the deadbolt turning, and I also forgot to include the Sonos notification in that video. So I have taken my beacon apart and put a little plastic thing back in to shut it off. What I'm going to do is I'm going to pull that plastic tab out
When I do, you should hear the Sonos go off in the background saying locking the front door, and you should see the deadbolt spin. So, all right, everything in view, here we go.
Locking the front door.
All right, there we go.
That's pretty much the project.
System is.
Let's go over here. So the way I put this all together is I started out with the Bluetooth beacon, and typically the Bluetooth beacon, you can set them up to broadcast whatever data you want on whatever schedule you want. But typically if you go get something like this, it's going to send out a little packet of data, which will have a major, a minor. Think of the major as if you're working in a company, and you have a whole bunch of beacons. The major might be the ID for your whole company, or it might be a certain location. The minor might be a specific building, or maybe a room in a building. And then the UUID is this beacon. And you can add data or set this up however you'd like. The next piece of data there is the RSSI. That's when the Raspberry Pi or whatever scanner you use, doesn't have to be a Pi by the way, but when your scanner detects the beacon, it measures the signal strength. And so that's the measured signal strength. And then the TX value is a calibrated value. We are working with Bluetooth here, and as everybody knows, Bluetooth is super accurate and always dependable. The other thing. So with these, if you're trying to do this and get any type of accuracy, you're going to want to set your own calibration value. So you'll set up a scanner, you'll put your beacon 1 meter apart, you'll see what that value is, and you'll set that TX value to be your calibrated value. Using those bits of information, we can calculate a rough guess on how far away the beacon is from the scanner. So this calculation, as I do with a lot of things, I found on Stack Overflow. All we're doing here in the first part, we set up some variables. Down here, if it thinks it's less than a meter away, this is not good for measuring inches. In fact, it's really not good for measuring short meter distances. So if it thinks it's less than that, it just kicks out power ratio to the 10. Basically, it's going to say 1. If it's longer than that, then this is the formula that I found on Stack Overflow. The constants that you see in there were from the guys who wrote the algorithm. They did a lot of testing in their environment, and those were the numbers that made it most accurate for them. This also was what was most accurate in my house when I was testing out the project. As I take these around and do it in different places, my calculation is probably going to be wildly inaccurate in here because of all the radio interference and wires and metal and all of that. So when you set this up, you'll have to adjust yourself. But to try and make it a little bit better, I do what's called a rolling average. So I take the last 5 readings and average those together. So every time I get a new reading, I dump a value, add a new value in. It's just basically a first in, first out queue. The way I set this up in JavaScript was I created a distance queues object, and then if I have not seen this particular beacon before, then I will use its UUID as the key, and then the value for that entry is going to be the last 5 readings. And as I get a new reading, I'm going to push in the new reading, and I'm going to shift out the old reading. So push and shift just basically says put one in the bottom, throw away the oldest one. Okay? And so from that, I just take an average of that array. So just the last 5 values. Then to try and make it, that kind of smooths out some of the peaks. And so to try and make it a little bit more accurate, I do what's called a weighted average. And so with a weighted average, so a normal average, you do like this. You have your distances 3, 4, 3, 5, 2 divided by 5 values gives you 3.4. A weighted average, you come up with some sort of your own method on which of those values is most important to you, and a formula to calculate that out. This is a very simple one going through the array. It's simply the index value in the array plus 1. So it's a 0-based array, so it's just 1, 2, 3, 4. 5, meaning the newest value coming in is going to get the 5. So it's the most important value, the one that's about to get shifted out, less weighted. So you just go through, take the weight, multiply it by the value in that position, go on through, and then instead of dividing by the number of values, you divide by a sum of the weights. So whatever formula you used here to calculate the weight, you're going to add those formulas together and divide by that, and that will give you a weighted average. You can find more information. I read about this on Wikipedia. It's a really detailed post up there. But as you can see, we held pretty steady, 343, went up a little bit, and then we dropped down to 2. So the weighted average comes out at 3.3. So it's a little bit closer. All right, from there, that's pretty much the function that I used to calculate the distance. And later on, you'll see in the JavaScript, I have taken that function and put it off in a utilities package. And then I also set up some other things, like when I use IFTTT and Home Assistant, and a couple other things I'll talk about. All of that's in a utility package that I'm not going to go through. If you're interested, I'm happy to go through the code afterwards and show you. It's all up on my GitHub account, which I'll show the link a couple times, and it's all open source, so you're welcome to use this for whatever you would like. But the next step we want to do is we want to build something to scan the Bluetooth beacons with. So on my Raspberry Pi, I want to install Raspbian, and I want to I'm going to use the headless version of Raspbian. If you're not familiar with that term, that just means it's Linux with no GUI. So it's all command line. They're Raspbian Lite, and they're the full version. There are some differences other than that, but I'm going to go with Raspbian Lite. So I use a program called Etcher. So I can download the Raspbian image, and then I select that image. I put my SD card in my computer, I select the SD card, and I hit the flash button. That's it. Really nice, easy program. It's got some safety checks in there to make sure that I don't flash that over the top of my C drive, because that could be bad. And so once that's done, I leave the SD card in the computer. There's a couple more pieces of configuration I want to do. Since I'm running headless, I want to be able to SSH into that Raspberry Pi, especially if I'm using a Pi Zero. The Pi Zero has, you have to get other adapters for HDMI and whatnot, and it works, but it's kind of a pain. You don't have as many USB ports. So SSH is nice. When you install Raspbian, it's going to put two partitions on your drive. One's going to be the boot partition, and one's going to be the file system, the root file system partition. If you're on Windows, you'll be able to see the boot, but not the root file system, so you'll have to use something like Windows Subsystem for Linux, I think it's called. What's that? Any type of a Linux emulator, you'll be able to see the other one. Before I had that in my old laptop, I just spun up a virtual box with Linux on it, and it gave it access to the card. But to enable SSH on a Raspbian install, all you have to do is create a file called SSH. There's nothing in the file, there's no extension. The easy way to do that is just say touch boot SSH, and that creates a file. When Raspbian boots up, it will see that file and turn SSH on. All right. I'm kind of lazy. I don't like typing passwords, so I prefer to use a key, an RSA key. So I generate my keys, and then with the SD card still on the computer, I create the .ssh directory in my home/pi directory on the card using the install -d. All of these things are they're documented way better than I'm going to explain them. So I'm just going to show you the code. My slides are available, and all of this is on my GitHub anyway. After that, using the cat of my public key, the double pointy arrow thing means take my public key and add it to the authorized key file. If it doesn't exist, it'll make one. And so that tells Raspbian, when it finally boots up, that my public key on my local machine is authorized. I don't have to type in a password. All right, and then of course, if it's something like the Pi Zero, I want to get the Wi-Fi set up ahead of time. So if you go to that big long directory to get to the WPA supplicant configuration file, and you just add an entry for network. The SSID is going to be, Blaine's network at home. Password's going to be, or the PSK is going to be my password, and then key management tells it what type of key management it's using, WPA, of course. And so with that file in there, when the Pi boots up, it'll automatically connect to my Wi-Fi. All right, so with all the pre-configuration done, now you put the SD card in your Raspberry Pi and you boot it up, and then SSH into it. Just simply the default user is Pi, so SSH Pi. Now to get the IP address, I typically just go on my Wi-Fi router at home and find it on there to get it that way. You could hook it up to a monitor and do it the hard way, but that's how I get the IP address. Once you get in, first thing I always do, even if it's something I'm just playing around with, PASSWD changes the password. When you set up Raspbian, the default password is Raspberry. And even though I am connecting with a key, the password's still available. So you could get into my Raspberry Pi with the username and password. So first thing I do, I change the password. Second thing I do is I run the apt-get update. And with that, I have a clean new installation of Raspbian. All right, so back to the project. For the project, I'm going to, of course, need to interface with the Bluetooth radios in the Raspberry Pi. The Pi 3 comes with Bluetooth. I don't think the Pi 2 does, but there are Bluetooth dongles you can put in those. The Raspberry Pi Zero W has Wi-Fi and Bluetooth. The regular Raspberry Pi Zero does not have Bluetooth, I believe. They're like $10, so they're kind of cool. Anyway, to get to the Bluetooth radios, you need to install these libraries. Once again, you can pull those up on the slides. No reason to read those off. I got them probably off Stack Overflow. If they ever shut Stack Overflow down, I'm going to have to relearn how to weld because I'll never be a programmer again. After that, you want to install Nodejs. If you install the headless version of Raspbian, it does not come with Nodejs unless they've changed it recently. If you install the GUI version, it comes with a really old version of Nodejs, so you'll want to take that out either way. So the first line is how to uninstall Node from, you can run it in either system. If it's not there, it'll just say nothing to do. After that, you have a couple options. You can install Node the regular way, or you can use Node Version Manager. I prefer Node Version Manager because I can go in and just say NVM, use Node 8, use Node 10, and you can switch back and forth for different projects. Really simple, really easy. That's the install from NVM's site as of, I think it might be a year or two old. I might have to update that version. But if they've updated the instructions, that would be the place to go. I would check there before you follow what's on my slide in case things have changed since I made the slide. But that'll get Node installed on your Pi with a current version. And finally, the Bluetooth libraries that we installed require sudo access, and I don't like typing sudo over and over again. So if you run this command, once again, I found this on Stack Overflow somewhere, this will grant Node, right here, you can see this will grant Node access to all of those Bluetooth functions that we installed previously. So then no more typing sudo. And then there's also some weird thing when you install Node. If you do it the regular way versus NVM, I forget, one of them has issues with sudo and the other one requires sudo. And so if you do this, you don't have to care. So I do this and I don't care anymore. All right, now back to the project. I like to work with environment variables for things that are part of the environment. So for each Raspberry Pi I set up to be a scanner, I give it its own ID. I set up an environment variable, your scanner 1. The beacon UUID, if I happen to, for some reason, want this scanner to only read a certain beacon or certain set of beacons, I can set that in the environment variable. I'm using IFTTT. If you're doing any type of home automation or hobby projects, IFTTT is a great website. It stands for if this then that. If you forget how many T's are in there, just count. But you can go in there and set up a REST call comes in, hits a certain function that you set up, and it'll make another call out to do something else. And you can chain all kinds of things together. I'm using this in the project to send the notifications to my phone. Originally when I set it up, I was sending out text messages. You only get a certain amount of text messages, and I'll talk more about that here in just a second. And then since I'm a database guy, I want my data in the database, so I set up ORDS, which is Oracle REST Data Services. I'll talk a little bit more about that in a second, but that requires my REST URI, which I store in there. so that my code will know how to get to it, and I can change these without having to recompile my code, which causes bugs even if you don't change anything. All right, to the code itself. So to scan for a Bluetooth beacon, I use a library called Bleaken. That very first line, that's that utility package I was talking about, so you'll see that here and there. The second line is Bleaken, and then I require Bleaken in there, and then I start the scanning by calling bleaken.startScanning. If I gave it a beacon ID, that was the one if I wanted to scan for a specific beacon, that would pass in there and it would only watch for that beacon. If I leave it null, it doesn't matter. So that's why that's set up that way. And then once it's started, you tell Bleaken on discover, meaning it found a ping from one of the beacons, go do something. Okay. The do something is that function that you put in there. It's a callback function. It receives a Bleaken object from Bleaken. And in that object, you'll find that UUID, the major, the minor, the RSSI, which is the measured signal strength. After I had everything working, I read the manual and found that there's a accuracy in there, which is Bleaken's calculation of the distance, which I've had mine be a little more accurate sometimes. I've had theirs be more accurate more often. So you could use accuracy. That really stands for distance. And then if you're not really interested in the numbers, you could use proximity, and that's just going to return words such as immediate, near, close, far. I don't remember all the words, but and they have their own little if distance thing set up. You'd have to look at the docs to see what that is. Here I call my calculate distance function that I talked about before, and then I put all the data out to the screen. So let's... Alt-tab works better than Control-tab. All right, so here I am already SSH'd into my Raspberry Pi. And by the way, the reason I'm using the network cable is because you never can tell if you're going to get everything working with Wi-Fi at once, so I just finally started using the cable. Here I'm using a Node module called PM2. It's basically a process manager. If you're going to do anything with Node or Python or a couple different languages actually, you can use PM2 to run your program and it will start it up. You can put a watch on your code, so if you change it, it'll reload your code for you. Really handy program. I highly recommend this for many languages, not just JavaScript. But I'm going to use PM2 to start.
Any specific reason you know?
What's that?
Any specific reason you use Node? You can use Python too, right?
Yeah, you can use Python too. I just picked Node because I was in a Node mood that day. I do a little bit of everything here and there. Now, let me just re-SSH in. I think I put it in sleep mode. Okay, hang on one sec. I broke something already. Let's get that. Put that, oops. Put that there. I tested this like 6 times this morning. What's that? Well, that's why I'm using the crossover cable. All right. When in doubt, turn it off, turn it on again. All right, I'll skip to the next part because I have like 3 repeated demos for that. We'll come back to that here in a second. And if I don't get it working, come see me afterwards and I'll make it work, because I get frustrated if things don't work, and I will work on it till it does. Pretty much the same code on this slide, but now that I know the distance, I want to trigger an action. I want to do something with that information. So top part's very similar. I get down to the bottom, I do my distance calculation, and then something simple. If the distance is less than 2, and it's in meters, so if it's less than 2 meters, then I call my IFTTT function that I have in my utilities package. I call that left room function. So if you remember in the video, when he first walked out of the room, it sent me a notice on my phone. That's all this does. I pass it the data for the scanner ID and the beacon ID, and then it pops up on my phone. Let's see if it's booted up fast enough. That might be why. Let's try it with the, apparently I was in the window and I was typing earlier, so I was like, what's a bearkin? All right, let me try that again. I'm in, okay. We'll skip the first one and go to the second one. So this is the one that we just were looking at, and PM2 not found. I don't know, maybe I dropped it. All right, so what that would have done is, I know why. Is it my firewall? So they give me a laptop. Yep, my firewall turned itself back on. And you can turn the firewall off. But it really shouldn't have affected. Oops. Go back to normal. So I'm SSH'd in, and I say PM2 start. I don't know why it's broke. And if I had more time, I would do that. Afterwards, if you want, I will run it. It works. Trust me. Don't trust me. Come see it. Anyway, that would call the IFTT function, which would send a notification to my phone. The piece that, little extra piece that you would have seen on that, sorry, now I'm thinking, that you would have seen on there is when I first did that, I was using text messages. IFTTT gives you so many text messages per day for free. And since this is going off every 2 seconds, my phone just started bing, 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 bing. I put a timer around that so it'll only send 1 notice a minute. And then it used their service so that that's free. All right, so from there, going back to the video, there was the message that showed up on my phone when he walked out of the room. There was the deadbolt locking when he got close to the front door, unlocking when he was outside, and then at the end there you heard the Sonos say locking the front door. None of my code, that's just using IFTTT to send the message. I use a program called Home Assistant. You can find it at homeassistant.io. It's an open source home automation application. It's basically the brain of your house. It's written in Python. It's a pretty active project. Lots of good stuff there. And that's what I use to tell the deadbolt to turn on and off. And it has a text-to-speech function that I sent to the Sonos, so it makes things come out. That really annoys my wife sometimes when I'm in that kind of mood, because I can make it say anything I want to. All right, so the next step there, collecting up the data. I want to get the data in my database. There is no Oracle driver for the ARM chip on the Pi, so I would rather use REST anyway. So Oracle has a product called Oracle REST Data Services, or ORDS for short, and there are multiple ways you can make a REST service using ORDS. If you're using SQL Developer, you can go in there, wizards in there, where you could go into a table, right-click the table, enable REST services, click a box, and you have a REST service up for that table. Or you can go in and build a module with a REST endpoint through another wizard by filling in values, or you can write a script like this. And so real quick in the script, this first little bit tells the schema that it's REST enabled. This next 2 bits creates a module with a template. Module and template are just building out the URI. So if it might be HR/customer, whatever you want the URI to be. And then the last part defines the handler. In this case, I'm watching for gets. If you're not familiar with REST, you can do gets, which means give me some information, and you can do a post, which means I have a record here. I'm going to give it to the server. I don't know what the primary key is, what the ID is. I want you to put it somewhere and tell me what the ID is. Generate one for me. Put is similar, except this one says I have this record. I'm going to give it to the server, and I have an ID. If that ID exists, replace the entire object. If the ID does not exist, make a new object and use my ID. So the slight difference between put and post. Put is more like an upsert. And then delete, here's my ID, get rid of that record. Whatever the server does with that information, that's up to whoever handled the stuff on the server. In this case, I'm doing a get, and it's just a simple select star from the reading table. All right, so the way we consume that is this is building on that previous example before, except for now I've added in the ords URI, and I'm including a node module called request to handle the REST calls. I'm going to create an array. I'm bad at naming things. I just called it alerts. It's probably a bad name, but that's always the hardest part for me. When I make a project, I'll spend hours trying to come up with good names, and I never do. But anyway, I named it poorly. That's what it is. The first thing it does is it does a GET request against that org URI, asking for the alerts for this particular scanner. So that way I don't have to reprogram every Raspberry Pi to handle different alerts. I can just leave them wherever they are. I can make a change on the database and just issue a reboot to everything, and they go get new data. So it makes it, I'm lazy. Lazy makes good ideas sometimes. So that's what that does, and then it just stores the body of that response into the alerts object, and then down here we go with the onDiscovered, just like we looked at before. Only here, every time we get that ping coming in, I post the data to the database where I store the scanner that detected the beacon it detected, and the distance that it calculated. So I have those three pieces of data going up into the database. And maybe that'll help. Wow, I don't even have sudo commands. Okay, I broke it good. Okay, so after that, so that's the data's coming in, putting it in my database. The next step is when I've detected the beacon, I want to go through those alerts that I downloaded and check to see, do I need to fire off an alert? So the first thing I check, I have a LTD alert that you can see in the red there. That means less than distance. Is the beacon less than a distance from the scanner? I have a modifier for that called start hour, meaning if I'm detecting if he comes out of the room, I kind of like him to be out of the room in the daytime, so I don't really need an alert for that. It's just at night. And actually, my son's actually not one of the runners at the school. They have some kids at that school that you have to hold their hand or they will run away, and they're fast. My boy does what he's told. He's a good boy. But he also is a good demonstrator. In this case, you can set a time limit around that. If both those come out to be true, then I'm going to look at the actions, and each alert can have multiple actions. And so I'll loop through the actions, and if it's the IFTTT action, I'll send a call to IFTTT. If it's the deadbolt action, I'll send a call to Home Assistant saying lock or unlock the front door. And then, of course, the fun one, Sonos text-to-speech, whatever I type in there and send, it says over the speakers throughout the whole house. And that entertains me. All right, so there's my GitHub repo with everything up to this point. Should be on that repo. If it's not, let me know. If I'm missing anything, I'm happy to help you get it all going, get that started. I have uploaded my slides to the conference, so if you forget that, my Twitter handle's on the bottom there, kind of low, and I will respond there. But that gets the project to that point. Just waiting for the, you got it? Okay. Didn't want to move it while you were taking the picture. It's okay. So there's more we can do with this information. So what if we have the beacon and we want to map where the beacon's at, say in this room? So this is some table data, and this is all real data. No, it's not. I made up some data so the numbers would work and it would be nice and pretty. But it's similar to the data that's going in. I'm storing the scanner ID, the beacon ID, the calculated distance, and the timestamp that it came in. And so this is showing 3 different scanners all tracking the same beacon as it moves throughout time. But timestamps are timestamps, so it's very, very unlikely I'm going to get 2 timestamps at the same time. So tracking scanner 5, 6, and 7 at a specific time, it's harder to do, so I round it up to the nearest 5 seconds, and I take another average, once again trying to smooth things out. And I found this on the asktom.oracle site on how to round to the nearest X units. In this case, I'm rounding to the nearest 5 seconds. Simply, we take the timestamp minus the epoch date, 1970, January 1st, and then multiply it by those numbers to make it into seconds. And once we have the seconds, we divide those seconds by the number that I want to round to. In this case, it's 5, could be 7. I divide by 5, I round off whatever the remainder is, then I multiply it back up by 5. I've now rounded to the nearest 5. Replace the 2 5s with 7s or 3s, and you're rounding to 7 or 3. Great little trick, found that on the Ask Tom website. Really smart people. So now that I have a known XY location for my scanner and a known distance to the beacon, the way we find where that beacon is in our plane is we use this thing called trilateration. That's fancy talk for Venn diagram. If you'll notice here, we have a pi 1, pi 2, and a pi 3, and we know where the XY coordinates of the 3 Raspberry Pis are. We simply take the XY, take the radius, we draw a circle. Where those 3 circles overlap, the beacon is somewhere in that zone. Being Bluetooth, it's not exact, it's somewhere in that zone. And so, like I said, trilateration is the fancy word, but if we're scanning with a Raspberry Pi, what's that going to look like? So imagine we're in a room, and over on this wall, we have a Raspberry Pi 0. That's, yeah, they're cool. They're about that big, and put Linux on it, 10 bucks. Over on this wall, we have another Raspberry Pi 0, and then on the front of the room, we have the Raspberry Pi 3 like this, okay? And the beacon is somewhere out in the room. If we do a top-down look, the dots on the walls are the scanners, and the dot in the middle is the beacon. So from here, we draw the green line. Here, we draw that green line. Where they all intersect, the beacon is somewhere in that red zone. Okay, easy enough. Well, all my data is in the database, and Oracle comes with a feature called Oracle Spatial. Oracle Spatial, it looks a little bit intimidating, but it is incredibly well documented, and there are so many different functions you can do with Oracle Spatial. I kind of geeked out on it for a while and really dug in, and I still don't know anything compared to some of these people out there. But it's pretty much based on what's called the SDO geometry object. And the way this works is the first number you get is your G-type, and that's telling Oracle Spatial, I'm going to make a certain type of object. In this case, it's going to be a two-dimensional polygon. You can look the numbers up in the table. The next one down is the grid system that you're going to use. So you might be using latitude, longitude, in which case you'd go, there are many longitude, latitude systems out there. There's not just one. There's a table about that big. So you pick the one that works for you, you put that number in here. I'm just using straight XY, so I left it blank. And then if I were only going to make a point, I would put data here. I'm not. I'm actually making a square or a rectangle, and that's what this next piece here says. That I kind of think they should have sequenced these better. So I'll come back to this one. This is my ordnance array. Ordnance are the XY points of each point on your polygon. Okay, and so that's why it says X comma Y comma X comma Y comma and so forth. Going back up to this one, this is telling Oracle Spatial how to deal with those XY points. Okay? In this case, it's just saying make a rectangle, so all I need are the XY points of 2 of the corners, and it will draw a rectangle, like so. Here's my query. This is my query that rounds to the nearest 5 seconds. You can see 5, 5, 10 there. Here's the average distance group by that I talked about. I can go through all these queries later. Sometimes I dig into these, but I'm kind of running short on time because my thing broke and I'm not happy with it. Okay, drawing a square. Here we run this query. This is SQL Developer, by the way. If anybody's not familiar with it, it's a free IDE from Oracle. When you run this, it returns an SDO geometry object. If you dig down in there, you can see that whole thing that fills out like what was on the previous slide. But this is a cool feature in SQL Developer. If you right-click on that, you can say Display Shape and see that I actually made a square. If we run the circle function, it looks similar, but if we click on that and display shape, we get a circle. One thing on the circle, you'll notice that the circle has 3 points. Since I'm using just XY and not a latitude longitude function, I don't have access to a special function that's built in that says give me an XY point and a radius and draw a circle. Instead, I have to give it 3 points on a circle. So for that, Once again, I'm lazy, I only like to do things once. I wrote my own function to make the 3 points on the circle based on the xy's. So I give myself the xy, and I have a radius of, say, 5. So here's the xy in the middle. I take x plus radius, gets me this point over here. Next point, I take y plus radius, gets me this point over here. Next point, I take x minus radius, gets me this point over here. And those are my 3 points, and it will make a circle. So I put that into a utility package off to the side. All right. And so this is what that function looks like. All right, so another useful function in Spatial is I have a circle and a square. In my case of looking for the beacon, I have 3 circles, but I can take 2 different shapes and run the function called SDO intersection, and it will return just that red zone. So it'll return a new shape, but only the overlapping piece, and that's what we can use to determine where the beacon's at, like we did in the top-down view. And so how do we use the, actually, let me show you one more thing here over here. So for example, in SQL Developer, we have a map view. So in map view, I can go into the query column here, and I can enter in all these queries I've been talking about. So this first query is just a square. That's defining my room. My second query is making a circle using my XY radius function, and then doing an intersection against the square, so that when I do that, it just returns that yellow object. My third one is a circle on the side. My fourth one is a circle on the other side. And then the last one is just an intersection of circle 1, get that object, intersect, or circle 1 in the square, take that object, intersect that, and circle 2, intersect circle 3 with that. So just kind of chain the intersects down, nest them down, and then that query pulls out the beacon somewhere in the red zone. Speaking of red zone, maybe you have a warehouse and you're tracking things and you have something where things are not supposed to be, or maybe people are not supposed to be. Whoever's carrying this beacon should not be in the red zones. A couple things we can do here. We could run a query that goes back to doing that, round it off to the 5 seconds, and then to get the three scanners all at the same time sync, and then do a historical query saying, tell me all of the timestamps when that beacon was in a red zone. Okay, there's a query, you could do it that way, or you could go back into the ORDS function where the data is coming into the database, and as soon as the data gets in, it fires off the query saying, is it in the red zone right now? If it is, I'm telling on you. So it can send an email, it can send a text, whatever you want to do at that point. But those are 2 different things you can do, and track where that little blue beacon is when it crosses that line. And there are things you can do, there are different intersection things. So this one's intersect by overlap, which means when it crosses the border, that's when it goes off. There are ones that are complete intersect that only count if it gets all the way in. With the Bluetooth, we probably don't even need to be that accurate because it's not that accurate. But if you're using something that is actually very accurate, you can get really detailed with some of these functions that are available from Oracle Spatial. All right, so what's this all cost? The hardware is a Bluetooth beacon, Raspberry Pi, and 2 Raspberry Pi Zeros. The software, on the other hand, is an Oracle database, Oracle REST Data Services, Raspbian, and Etcher. So raise your hand if you think the hardware costs more. All right, got a couple. Everybody thinks the software costs more. All right, so what's that? All right, so for the hardware, we have the beacons are about $7 on Amazon if you buy them single. They get cheaper if you buy them by the pound. The Raspberry Pi Zero is around $10, and that's just the board. No power adapter, no SD card, just for the board. Pi 3s are around $37 last time I checked. Once again, just the board, no case, no power supply, just the board. Software. The beacon scan software, I wrote that. There's my GitHub account. It's an open source license, MIT, I believe. Use it all you want. I'll even help you out if you have trouble. Oracle database. Everybody associates Oracle database with budget because they're nice and cheap. Oracle XE is completely free. You can go to oracle.com/XE, download it. It has all the features of a full-blown Oracle database. It is a full-blown Oracle database. The limit is the amount of data that you can put in there. I believe it's 12 gigs. It might be couple more. It's somewhere around 12 gigs. It's 12 gigs? Okay. But it does come with advanced compression. So that 12 gigs can get really bigger if you turn on the advanced compression feature. So you can get more in there. ORDS is free and included. You can find ORDS at oracle.com/rest. Raspbian is free and open source. Etcher is also free and open source. So the hardware is the only thing that actually costs money in this project, and you don't actually have to use the Raspberry Pis if you don't want. They're Bluetooth modules in your laptop. You can use the Bluetooth in your laptop to do this exact same thing. All right, and so recap, we talked about Bluetooth beacons, what they are, how to set up your Raspberry Pi. We looked at the code a little bit. My code did not run. And then we set up Oracle ORDS. We talked about ORDS and Spatial, ran through some queries. Any questions? Yes?
I heard recently that IFTTT is dropping being able to send an SMS. Do you know anything about that?
I do not. I've just been using their app ever since because I bumped up against the charge you for text messages in general on this project, and the app, I like the app anyway. I have it hooked up. I have a thing called an Open Garage. It's this little thing, you screw it to your ceiling, and it has a distance sensor. So if the door's open, it's like 120 centimeters to the door. If the door's closed, my wife's car's in the garage because I don't get to park indoors. It's about 160 centimeters. If the door's closed and there's nothing in there, it's about 300 centimeters to the floor. And so I can run that with IFTTT. And that's one of the things I use. But I stopped using, since I have the app to do that, I just use their notifier. So I haven't tried that. Any other questions?
Can you use direct anything, any Bluetooth, like you don't have to pair at all, you just
Right, I actually have a Raspberry Pi set up to be a beacon. You could set your laptop up to be a beacon. Just use that beacon software. It has ins and outs to do that.
If you have any other dongle, you can have another dongle.
Yeah, I've got a whole pile of those little Bluetooth dongles that I used to use for headsets.
As a beacon,
What's that?
that you use the dongle as a beacon, you connect to something else.
I haven't tried it, but I don't see any reason you couldn't. Yes?
Almost Bluetooth 4. Sounds like you were testing out the space and measuring various levels to get the distances in RTTI. Did you do that in empty space, and what happens when you have like a party? And like, could you still get good results there?
Yeah, so I did all that in my house, and my office is in the basement in the back corner, and I've got the windows all covered up because I like caves. And so I did all my testing down there, and then when I moved upstairs, it was kind of nice because of the way my house is laid out. You saw him go down the hall. The two beacons didn't accidentally set off more than one at a time. But the part that I couldn't run, part of that I take my beacon, and while it's detecting, I do this, and you see that it adds about 6 to 10 meters just by doing that. I can get 5 by doing this, so not super accurate. You had a question.
The application of IFTTT, do they require installing an application on the phone?
Yeah, that does go through the IFTTT app, but then it's just a notification on the app itself. It looks like a text message, but it's just the app. Yeah. All right, if you have any other questions that I haven't answered, I try very hard to answer all of my contact points. My blog post there, Learn Code Share. If you want to try out Oracle XE with ORDS, my last 2 posts were on how to set up an Oracle XE database with ORDS installed, fully up and running using either Vagrant for a VirtualBox or on Docker in 2 separate containers, and all the code's up there, and I'm happy to help out with that as well. So thank you for spending your time with me.